Okay, let's talk about the four-letter F word. I think you know what I'm talking about. No. That's right. I'm sure this is what you were thinking. Flipping. And that's what we do. That's what reciprocals are. So what we're going to look at now are the reciprocal functions to tangent, sine, and cosine. We'll do cotangent first, and I'm going to cut through a lot of the other stuff that I showed you with tangent. I could go through the same motions that we did when we were talking about what the asymptotes are for tangent, and yada, yada, yada. But you write this stuff down. For cotangent of theta, okay, your asymptotes, because again, this is x over y, right? So we're flipping over the tangent function. The two main differences with that. So the asymptotes aren't going to be at negative pi over 2 and pi over 2 anymore. The asymptotes are going to be at 0 and pi. So what does that mean? That means when I go to graph this cotangent function, when I take that phase shift, that stuff that's inside the parentheses, I'm going to set it equal to 0 and pi instead of negative pi over 2 and pi over 2. Instead of 0 and 2 pi, as we were doing before. The second thing is, because we have that four-letter F word, flip, cotangent is the flip of tangent. So a tangent graph is supposed to do this. How do we flip that over? A cotangent graph is supposed to look like that. So yeah, that tangent graph that we graphed a little bit ago, it looks kind of like a cotangent graph when we take the opposite of it. So, let's do one real quick. Let's do negative 2 plus the cotangent of 3x minus pi over 2. Alright, so we're going to take the phase shift. We're going to set that equal to 0. And we're going to set that equal to pi. Right? Not negative pi over 2 and pi over 2. Not 0 and 2 pi. 0 and pi. And these are just things that you kind of got to keep straight. You want to call it memorizing? I can explain why it's 0 and pi, but again, it goes along the same lines as when we were talking about tangent. Multiply everything by 2, 6x minus pi equals 0. Add pi, divide by 6, x equals pi over 6. So our first asymptote for cotangent at pi over 6. Multiply everything by 2, 6x minus pi equals 2 pi. Add pi, divide by 6, you're going to get 3 pi over 6. Now, 3 pi over 6 is pi over 2, and you can write pi over 2, but I think in this sense it makes sense to leave it as sixths, so that when we scale our graph, we know we're going to scale this by sixths. Because if you go from pi over 6 to pi over 2, not having a common denominator there will complicate things for us a little bit. So we know where our asymptotes are. Pi over 6 and 3 pi over 6. So when we go to graph this, when we scale our graph, let's make our scale pi over 6. So here's 1 pi over 6, 2 pi over 6, 3 pi over 6. So these are my two asymptotes, and just like tangent, cotangent, actually, yeah, we're good. Cotangent has an intercept right in the middle. However, now that we've taken care of all of this stuff, let's look here and here at the vertical transformations. So what are we doing? Are we flipping this graph? No. Are we stretching this graph? No. All we're doing is moving it down 2 units. So this intercept is now down here. And because this is a cotangent graph, which is a flip of tangent, instead of going this way, we're going to go this way. Okay? And that's kind of bad. What I drew right there was kind of stretched out. We want to see more of a bend to this graph. And then we're going to move to the other side here to graph more of these. Right? Cotangent. We take tangent and we flip it over. Now, if this was negative, let's talk about it. If that was negative, I'd flip this over and we'd have a tangent looking graph. Right? But it wasn't. It was positive. So cotangent does the opposite of tangent because it's the reciprocal of that. Okay? Subject to phase shifts, subject to vertical transformations just like before. But when we vertically translate, we either flip it over or we move that intercept point up or down. And that's it.